at first the autopsy showed nothing, but then they sent her heart out. And that was shocking because my sister had been diagnosed 10 years earlier with dilated cardiomyopathy, but the physicians had told her that there was no family history, she didn't have diabetes. This was caused by a virus. First I heard of long virus stuff, long COVID. You know, it was a virus, it was a fluke, you've got this dilated cardiomyopathy, but there's nothing we can do about it. Well, I'm a geneticist, my sister, my niece, it seemed to me this was genetic. So I set out to try to find the cause, and I was a member of the Yeast Genetics Club in Chicago. I talked about this wherever I went, and it turns out that Elizabeth McNally's husband was a yeast geneticist in this club, and she was the premier genetic cardiologist in Chicago, probably now in the world. And she took on our case. I became her patient, and she sent my sister's DNA out for testing, and no, it didn't have any of the 5 or 6 genes they knew of at the time. And every couple of years she'd send out again, and no, it didn't have any of the genes that they knew of at the time. Eventually, about 10 years later, you know, it cost, in 2003, it cost, do you guys remember how much it cost to sequence the human genome? $1 billion, $1 billion. Well, 10 years later, it cost $50,000. Elizabeth McNally had a grant. She could afford to sequence 5 of her patients' genomes for $50,000, so she did. By the way, now it's not $50,000, it's less than $500 to sequence your whole genome. So, you know, this is part of the problem. Doctors and medical students can't get used to this price change, and they still think if it's not $1 billion, it's $1 million. But, you know, we can afford this. It is not that much money. Anyway, sequencing the whole genome, of course, there's 20,000 genes, and they all have changes. There's a little change here and a little change there. How does she decide which gene is the one? Which change is the one? And this is where Dr. McNally's knowledge of cardiology was so important, because she wasn't looking at genes they already knew. She wanted to look at new ones, but she couldn't look at them all. So she focused on ones that she thought would be related to the heart. And that included the filamin C gene, because it had a muscle component. It was a muscle component that was in the heart. And my sister had a change that messed up that gene entirely. It you know, sort of in the middle, the rest of it was no good anymore. So it looked like pretty good smoking gun. She didn't tell me because she wasn't sure. And then she moved from University of Chicago to Northwestern University, and I moved to Reno, and she never answered me again until my sister died. And I instead of writing to the genetic counselor whom I had been writing to, I wrote to Dr. McNally, and she answered me immediately. So her mail wasn't being forwarded, her email. You know, you can't trust email these days. You have got to call. And she, by then, felt more secure about this gene. She told me about the paper, and other people had written. Actually, do you guys remember John Roth? He's a geneticist guy who worked on onset suppression. Well, his son, Fritz Roth, published a paper with this exact same mutation that was in my family. Exact same one. And it caused the exact same thing it caused in my sister's family. But the patient had checked off, don't bother me, I don't want to hear from you ever again. So there was no way to contact this patient. But there were other cases of similar mutations. And what they did also was to look in model systems, not in yeast, but in an organism that actually had muscle. And it looked like this was the right mutation. And when I did a Google search, actually I spoke with the genetic counselor, and I asked her, you know, do you tell people when you find these mutations? How do doctors know about it? And she said, well, there's this new thing called ClinVar. And this is a website where everybody, doctors, patients, well, not the patients, the doctors of patients, and the genetic researchers and genetic companies put their data into this place. So I looked it up, And there were 2 other mutations that were exactly the same as mine. Well, this is a pretty big gene, and anything in it could mess it up. How come they were all having the exact same mutation? It didn't look like this was a brand new mutation in my sister. I was hoping maybe I couldn't get it because it was brand new in her. No, this thing seemed to have been around because a lot of people had it. And when I looked it up in the inflammatory bowel disease registry, there was a big genetic study of control people and people who had inflammatory bowel disease. And a lot of those were Ashkenazi Jews in that study. It was a study out of Stanford, and 1 in 800 Ashkenazi Jews, controls, not the inflammatory bowel disease people, had this mutation. But nobody else did. None of the other ethnicities that were looked at. So it looked like it was a founder mutation, a mutation that began in an Ashkenazi Jew many years ago. Of course, many other people have mutations in the same gene. You know, it's an equal opportunity killer. But this particular mutation was an Ashkenazi Jewish mutation. So there's a big gene, and you could have mutation anywhere in it that could mess you up. Ours is right here, and it says A to G. But everybody else's could be C to T or something else, somewhere else. Question?
So what's a founder gene?
So the founder gene is maybe 500 years ago, off in Poland somewhere. There were a bunch of Ashkenazi Jews, and they, by chance, somebody had this mutation. And then there was a pogrom, and they were mostly killed. And there were only a few Ashkenazi Jews left, but one of them still had this mutation. And they intermarried for the next many, many years, centuries. And so that mutation that began as a rare mutation in this particular population became a very common mutation. And that's what's called founder. And BRCA is a founder mutation. There are a number of Ashkenazi Jewish mutations that are founders. Other people get mutations in these same genes. It's just that it's spread out more. And sometimes by knowing the mutation, you can find out more of what it's doing. So that it has been some help. So that's the story of how we found the mutation. And once I found it, I wanted to find family to warn them about it. And one of these things I have here is connect my variant. So I spent a lot of time becoming an amateur genealogist. So I would find people to warn them about this mutation. And that is something that this nonprofit, Connect My Variant, tries to help people do. So whether you're Jewish or not Jewish, whatever mutation you have, if it's inherited, if it wasn't new in you, other people have that exact same change. And if you all register, they can help you with volunteer genealogists find further relatives. So if you're interested in that, pick up this card from the Connect My Variant organization. So one of the things that I feel strongly about is getting genetic testing. People often think that, well, if it's not in the family, if it's not hereditary, if I don't know about it, then I don't have to worry about it. But in my family, we had no idea that there was any hereditary heart disease. Now, looking back, I can figure it out. But my father died suddenly at 66, heart attack. His mother died in her sleep at 59, heart attack. His brother died at age 4. And they said a big dressmaker's mirror fell down on him and killed him. Well, when I did the research for this book, I discovered that there was no accident. He died from heart failure. So it's unusual for a child that young to be killed from this mutation. So there may have been 2 mutations, it may have been a virus and a mutation, but it was certainly this mutation. The other thing is that with often doctors are told that if you know the cause, if it's somebody is overweight, if they have diabetes, if there's a reason for their heart failure, then it's not genetic. But that's not true. 1 in 5 cases, it's still genetic. And so cardiomyopathy, half of the people who have cardiomyopathy have a mutation causing. What percent of the people you think who have cardiomyopathy get advised to get genetic testing?
1%.
1%. It's just incredible that we have to break through this. Doctors don't know, they're afraid, they think it costs $1 million. It's not that expensive. They're also frightened of genetics. Genetic counselors are there to help them and to explain the genetics. They don't have to be a guru in genetics. The other thing is, if you do random testing, if we just test everybody, 1 in 6 of us are going to have a mutation in what we call an actionable gene. So let me explain that a little bit. There's no point in hearing that you have a gene that causes Alzheimer's because we don't have a cure. There's no point in learning that you have a gene that causes Huntington's because we don't have a cure. But learning that you have a gene in the FLNC gene, you can do a lot. You can get a defibrillator, you can get your heart checked every year. If you have dilated cardiomyopathy, you can get on beta blockers, and you can prevent, not entirely, but you can much lower the chance of getting sick. Same thing with cancers. Knowing you have BRCA, there are things you can do. There are 81 genes now that they argue about, but that the American College of General Genomics has decided are actionable. They cause cancer, they cause heart disease, and they cause a variety of other diseases. But for some reason, they don't recommend testing. What they say is, if you have cancer and you get tested for the cancer genes, and while they're testing for the cancer genes, they find the FLNC that causes heart disease, you should tell your patient. But we don't have the money, we don't have the expertise, the doctors will get scared, we don't have enough follow-up, we can't recommend general testing. They're arguing about it, they're considering it. I don't quite understand it.
Who is they?
Pardon me?
Who is they?
They is the American College of General Genomics,
Okay.
who has decided on these 81 genes. They have many committees and they fight over these genes. So I called my doctor to thank her for getting FLNC included, and she said, oh, talk to Adam Gordon, he's the one who did it. And he said, we had it in the list, and then the next year people said we should take it off the list, and we had to fight about it and keep it on the list because they only want genes that they really feel are actionable beyond lifestyle change, that really are actionable. So working on these 81 genes, the other concern is, in certain families, certainly in any of the families that have been studied for FLNC, it's very clear that it causes heart disease. And actually, let me talk about that for a minute. Just because you have a mutation doesn't mean you're going to get sick. You can have the FLNC mutation and live your whole life and never notice it, die of something else. However, the penetrance, the chance that you'll show something is about 90% if you go to a cardiologist and if they test your heart and look for things. If they don't, you have a 50% chance of coming down with heart failure. That's pretty bad. And a 15% chance of dropping dead like my niece. But it's not everybody. It's not an immediate. So a lot of times people are frightened to get tested. They don't want to know. It's going to mess up my life. God forbid I'll have to have a defibrillator. I don't want a defibrillator. If I just don't know about it, I won't need it. Unfortunately, it doesn't go away by your not knowing about it. And fortunately, going to a doctor once a year, getting a defibrillator if you need it, really isn't as bad as it sounds. I have a cousin, a relative through marriage, who, for a different reason, has a defibrillator implanted since his childhood. He has a beautiful wife, a beautiful daughter, a great job. He has a wonderful life, and he's alive. Of course he needs the defibrillator. Why wouldn't you? People who are afraid of learning this have not lost a daughter. That's what you need to be afraid of, not that you get a genetic test and it's going to tell you something. I ask people to think of a genetic test like you would think of getting a blood test, getting not a blood test, a blood pressure test, a cholesterol test. We're not afraid of those things. We're not going to die because we have high cholesterol. Well, we might, but if we change our diet and we take the appropriate pills, our chance of dying from high cholesterol goes down. Same thing with high blood pressure. There's things we can do about it. The same thing with any one of these 81 genes. There are things you can do about it. And so I would like to see this paid for everybody, that everybody be able to get this test, and it be recommended. And that's part of what I try to make the argument in the book. ClinVar also has their list of actionable genes. Instead of 81, they have some 400 genes they think are actionable. So, it depends how you look at it as to what's actionable. And one of the concerns that I think is a true concern is just because in my family and in the families that have been shown to have FLNC killing, doesn't mean that if you have an FLNC gene in some other ethnic group entirely, it will have the exact same effect. We don't know. And it's possible that it won't be as lethal. And so we have to be aware of that. But to me, not testing is too extreme. Be cautious if you find it in a different ethnic group. Don't immediately, for FLNC, going to a cardiologist once a year, well, that can't really hurt you. If it's a BRCA mutation and they're going to start treating you to remove organs to save your life, you want to be sure that you need to do that. And so different levels of looking into that. In the book, I list a number of genetic testing companies that I recommend. Unfortunately, genetic testing has changed a lot, and it keeps changing. It's like anything in medicine now. It's a little obtuse. It used to be a little more obvious what you were paying. Now they've joined, and LabCorp has taken over my favorite company, Invitae, and I'm sure it's going to get better, but right now it's gotten a little bit worse. But I did want to mention that I did find a place called Picture Wellness. It's part of Fulgent Genetics, and it offers a $295, and I'm not selling, I'm not connected with them in any way, $295 self-pay test for the 81 genes. So, I think it's probably a loss leader because Invitae had that for 300 and the 350, and they've sort of gone under. But take a postcard if you're interested, if you can afford the 300. If you find a mutation in one of the 81 genes, you certainly can warn your children, your siblings. I know some of us are a little past the point we're really worried about it for ourselves, but I would like to see this be much more widespread, and at least there is this one company that is providing testing. So I don't know how far I've talked and talked. You were going to ask questions, but instead you talked and let me talk. So the other thing I wanted to do was to mention something about my family, because part of this book is genetics and my coming of age as a geneticist. I knew Mike years ago, and Ping was my student, and the struggle as a struggle and privilege as a woman in science, and I had a wonderful time at MIT, actually. But part of the book is a love story to my family. And so I just wanted to say that even with a death sentence or a problem, a health problem, one can still have a wonderful life and a wonderful family. And my father, so there are vignettes about my family. My father used to tell me all the time, do your best and leave the rest. Because I'd be there studying in high school and worrying, would I get this, can I get into MIT? And he'd say, just go to sleep, do your best, leave the rest. And every night. And the other thing he used to tell me was, learn to be satisfied. His father died when my father was 16 and his father was 40. He had to go to the army. He had a tough time. And he says, if there's no earthquake today, just like Eeyore, if there's no tragedy, if someone you love didn't just drop dead, you have to celebrate this day. Be satisfied. And he just loved life by doing that. When he turned 50, so when he was a young man, he had two jobs. He was a teacher in high school. He taught office machine stuff, and he also opened his own business. But when he was teaching in high school as a student teacher, one of the teachers was 50 years old and died suddenly of a heart attack. Well, my father's father had died some years earlier at the age of 40. And so his response was, at least he lived a good life. Well, you can imagine the other faculty were not very pleased with him. And it's very unusual for him to have people think he was callous. So when he turned 50, he stood up in the Passover Seder and he said to us, he rang the bell on the wine glass. He said, now I can say it. I'm 50 years old and my bags are packed. I'm ready to go. I want to live longer. But my children are grown. I had, more or less, I was still in college. They don't need me. I've had a wonderful life, a wonderful wife. I'm ready to go. And he lived another 16 years. My sister was a teacher, and she used to have parents come to her complaining, I wish my first grader was out playing football and, reaching that basketball better and doing this and that. And she'd say to them, celebrate your child. Learn to celebrate your child. And that was her statement on life. My mother used to say, this too will pass. Whatever trouble there was, she would say, this too will pass. So I'm very thankful for my family, and perhaps I've talked enough, and I could do some reading or answer questions. Why don't I answer questions? Yes?
Are you familiar with the NIH program, All of Us?
That, I'm not that familiar. Was that through the Army?
No, it's through NIH, and it's one of Francis Collins's big things. It's a human genome population survey.
Uh-huh.
And so they pass around cards at medical centers and doctors' offices and stuff, and ask people if they want to be part of this.
Uh-huh.
Just tell their physician, and you give a urine sample, a saliva sample, and a blood sample.
Yes.
And then you volunteer to have a sequencing of your DNA done, or you can decline.
Uh-huh.
And you can volunteer to get all the information, or you can decline. And then they eventually will give you the list of actionable genes.
So,
and it's free.
What action? So we have something like that in Nevada that's called Healthy Nevada, and they sequence your whole genome. I did it, and they will tell you for free about 15 genes. It's tier 1.
I think this one was maybe 20 genes.
20, so it's tier 1.
A huge number.
Yeah, it's the tier 1, which is fine, which is great. It's something, and it's free, and it's wonderful. Yeah, I would advocate for a few more genes, but
Sure.
And I don't understand, since they're sequencing your whole genome anyway, why they can't tell you for all of them, why they have to only limit it to the tier 1. But that's what they do in Reno.
Hierarchy they're working with, or certain targets they need to reach. I don't know.
I think the people in Nevada tell me it's because you can't overwhelm the doctors. They don't know what to do. If you can't follow up, there's no point telling people. They'll be frightened, and the doctor won't know what to do. To me, you educate the doctor, but.
Well, I don't know when doctors are involved with this program.
No, so you suppose you find something.
Right, you can volunteer for genetic counseling, or you can decline.
But even if you get the genetic counseling, you need to then have it, if it's actionable, you have to get a doctor who will help you.
Right.
And they're claiming there aren't them. So therefore, don't tell you.
I'll take your word for it.
Yeah.
For sure.
Well, that's what they say in Reno. In Nevada. I don't know what the answer is. Yes.
I don't know if this is a urban legend or what, but I've heard that some of the descendants of the survivors of the concentration camps have shown genetic anomalies. Have you heard anything that?
Unless they were treated with, mutagens that caused a genetic anomaly, I don't know.
That the trauma impacted the genetic structure?
Epigenetics or something?
Yeah, I'm not familiar with that. I don't know.
Thank you.
How does it affect the heart? It's causing a cardiomyopathy. Is it actually involving the muscles itself, or is it neurologic somehow, or people don't know?
They may know,
But it's
but
not-
it is part of the muscle. But you can die when your heart is perfectly fine. So having a
Oh.
cardiomyopathy, you don't have to have cardiomyopathy. You can have arrhythmia. So
With this gene.
with this gene,
Oh,
yes. So
interesting.
what we discovered, what we knew was the original recommendation from my cardiologist, Elizabeth McNally, before we knew the gene, was get an echo every year.
Yeah.
And that'll sort of protect you.
Huh.
But then when we found out the gene and we found out what happened to patients, there were people who died who had perfectly normal hearts.
Echoes.
So that you had to get an MRI, you had to get things that would check the arrhythmia of your heart.
Okay.
And if that was wrong, then you needed the pacemaker, you needed the defibrillator.
Right.
But then there's the other problem of dilated cardiomyopathy. So you needed to check that if you had something wrong with the shape and size of your heart, then you would need to be on beta blockers as well. Yeah. But this is just one mutation. There's many, many mutations that can cause heart disease, cancer, and others, and all of them can be treated. Not all of them. The ones that we have, it's 81 that are agreed upon that can be treated. That I would love to see people treat, and doctors become less afraid of. When I started writing this 5 years ago, because it's been a year it's finished, I thought by the time I finished it, genetic testing would be routine. You wouldn't need this anymore. But it turns out that's not true at all. So what happened was I was very involved with finding relatives and to try to track down the gene, then to find relatives to warn them. And at the same time, pandemic came up. I don't know if you guys remember pandemic. And I was in a book club. And I became the head of this book club on Zoom because I could run Zoom. And they didn't want to read anything heavy. I mean, we were too upset. We did not want something serious. So I picked out a book called The Adventures of Mrs. Polyfax, or The Wonderful Mrs. Polyfax. Do any of you remember Mrs. Polyfax? Oh, somebody must know Mrs. Polyfax. You know Mrs. Polyfax. All right. Well, when I was in my 40s, Mrs. Polyfax was an old lady. She was 65 years old. And I was in my 40s reading this Mrs. Polyfax series. She was bored with life. She didn't want to do the cooking club. She was tired of being retired. She wanted a life. She went to her doctor. He said, do something, get a life. And she says, oh yeah, I always wanted to be a CIA spy. And she goes off, and in the next bunch of series, she's a CIA spy. Well, now I'm in my 70s and running this book club, and I'm reading this thing, and this is this young 65-year-old woman running around the world being a CIA spy. So it was very fluffy. It was, World War II anachronistic, and there wasn't much to discuss. So the question I asked the group was, what haven't you done that you always wanted to do? And for me, the answer was I had always wanted to write a book about my life. So I started, and someone in the group who was a memoir teacher, whatever, she helped me. I started writing just little things about my life for that reason. And on the other hand, I was doing all this genetic stuff. And then a couple of years later, I just sort of married the two together, and that's what came out with the book. So, yes?
What are you doing to educate the medical profession, the cardiologists, the primary care doctors? Are they inviting you to the national meeting so you can keynote?
No, they're not.
I'm a retired physician, and I'm attracted to think about, this.
I would love to get such invitations. So I have spoken in Reno. I got to speak to continuing education. I talked them out of charging me $500 to give the talk. And I gave it in their continuing education group. Then Ping invited me to talk in the cardiology department at UC Davis. And then I discovered that UNR was having a whole series on genetics, and I got myself invited to talk again on that. I've asked in a number of other schools. I mean, I've gone to University of Rochester, Harvard. All of these have medical schools, and I can't seem to find the right person or break through. I keep trying. I do speak in the medical school at UNR, and now they've changed the program so they don't have genetics, cardiology, blah, blah, blah. They have a patient. And so I go in there when they do cardiology and they have a patient. And they talk about this patient, and I'm always shocked. I don't think it's just UNR. I think it's a lot of places. You go in there, they tell about the patient, he has cardiomyopathy, and I've given them literally 15 minutes worth of reading that they have to do. Like the slides that tell them that it costs $250 to get the test, the slide that tells them that half of the people who have cardiomyopathy have a genetic cause. You ask them, should you do a genetic test on this patient who has cardiomyopathy? And they say, no, it's much too expensive. I mean, you know, it is going to take forever to break through.
That right?
You know, not every student, but more than half give that answer. There's a few who've read it and say, no, it's only $250 panel. And yeah, half the people, you know, but it's going to take a long time. So.
Don't give up.
You know, the thing is, in American medicine, because of our strange economic system here that we have for medicine, there's things that are covered by insurance and things that aren't. I recall maybe 20 years ago, I read in the cardiology literature actually about a blood test which was predictive of arteriosclerotic heart disease. Being a guy in his 50s, I said, I should probably have this test. So I went to my doctor. I said, at that point, since then I discovered I have some things wrong, but I didn't then. So I said, I'd like to do this test. He said, oh, we can't do that. It's not covered by insurance. So I asked, well, how much does this test cost? So he said, well, I'll look it up. I said, $12. Do the test.
Yeah, unbelievable. Yeah, yeah. So I did also bring some pictures.
There's one more question.
Oh, I'm sorry.
Do you think it'll come to the point where 23andMe and as become more popular will also do genetic testing?
Well, I don't think they're letting them do genetic testing, clinical genetic testing. They did initially have some genes that they tested for, but they didn't want them in that arena. So Ancestry, 23andMe are not clinical genetic testing, and they're not really sequencing. They're using some kind of restriction mapping kind of thing where they're just looking at very few genes. There are, however, consumer-based companies that will, without a doctor's prescription, sequence your entire genome for $500 or so, and sort of give you the DNA sequence to work on yourself. I mean, and they don't seem to answer any emails when I ask them questions. It's like, so I can't really recommend them yet, but someday they will be good, is all I can say. There's one run by Dr. Church, who was involved in DNA sequencing, and I asked them about the 81 genes, and they said, well, here's the list, and you can always search yourself. I mean, I can do this, but it's not something I would recommend at this stage. But the good news is, next year when it's 85 genes, or the year after when it's 89 genes, you don't have to get your sequence done again. You can just look it up. But if you're working with Church, you have to pay $200 a year to keep access to your DNA sequence. So it's not a cheap I mean, it's not 50,000. You're talking about 500 and then 200 and then it goes down. It's something you could do, but it's not that easy to understand what they're going to tell you about the genes because they're not being transparent. Yeah.
Well, one of the problems that's behind that is there was a time in this country when anyone who wanted to could do testing of clinical samples before genetics really came about, at least when it was biochemistry. And anyone who wanted to could say, well, I have a lab test, it's interesting, you should do this lab test and see what's wrong with you. And there was a real problem here because a lot of these were scams, and a lot of the people weren't really prepared to do anything by current medical standards. So for very good reasons, they put in certain certifications. So if you're working in a lab as a researcher like we do, you can do that. You know, you go into the lab, you do the research, if you can talk someone into funding your research, you can do it. But if you're dealing with patients and you're doing clinical testing, you have to meet certain clinical laboratory standards.
Right.
And so that's part of the problem, is that these people from 23andMe are probably perfectly good sequencers. They're probably among the best in the business, but they don't, they haven't demonstrated they've met those clinical standards.
So I actually did a research project in my lab on, I thought I can find a whole bunch of Ashkenazi Jews who have cardiomyopathy, and I wonder if most of them will have my mutation. It's PCR, I can sequence it, I can do this very easily. This was before sequencing was so cheap. Well, it turns out most people who have cardiomyopathy don't know they have it until they die. So it wasn't easy to find those people, but I found 7 Ashkenazi Jews with dilated cardiomyopathy, and 3 out of the 7 had the mutation in my family. So 4 had other mutations. I mean, it's other mutations, right? I was instructed that I needed to tell those 3 that they had to go to their doctor and get my sequence confirmed, because mine was just done in a lab. I could have made a mistake. I don't have the CLIA, I don't have the criteria. So I told them to do this, and one of the women told me that her doctor refused. He didn't know how to do this. He didn't know why to do it. He didn't want to do it, blah, blah, blah. Well, she had actually died and been revived and given a new heart years earlier. So she had another doctor that was involved with her heart transplant, and they did it at Johns Hopkins. They did the sequencing, and yes, she had this mutation. So they also told her it was caused by a virus. And it didn't matter what I told her, she still was sure that it was caused by a virus. Once you tell somebody something, so I don't know if she ever warned her family or not, because she still thought it was caused by a virus. But she had this mutation. I don't think it was a virus.
Do you know Rachel Raymond?
I do. I don't know her well. I actually asked her if she would read the book for Rachel. So my husband, actually, let me go back. We had good friends who gave us her book, My Grandfather's Blessing. And that is part of the reason I have this little vignette in the beginning of each chapter, because that's what Rachel Raymond has in her book, and that I loved her short stories. And this began with just being a series of short stories. So we used to read her short stories every Friday night, my husband and I, ourselves. And then pandemic came, and he had to run the service in our synagogue. And he's not a rabbi, and it's hard, everything's on. So he decided that he would just read one of her short stories as the Devar Torah, so to speak, every Friday night. So for years, our synagogue was reading her short stories. Then the synagogue was 100 years old, and we needed a speaker to come. And one of the congregants said, let's ask Rachel Raymond. We've read all of her stories. And they wrote to her. She's an old lady now. And apparently the person reading these said, oh, we'll throw it out. Oh, no, 100 years, this is important. And so she, on Zoom, on tape, was our speaker for 100. And then I did a portrait of her because I'm an artist.
Because she's a genetic counselor, right? That was the latest thing that she was doing. She got into genetic counseling.
Rachel Raymond.
Yeah, she switched, from, and she got in. So I was thinking maybe she can connect you with people in different hospitals or something, where you can go and talk to them.
Rachel Raymond is the right person, right? Okay,
Yeah,
I had the right one. Okay, so she was a cardiologist. She was a doctor, and she had Crohn's disease.
Yeah.
And she woke up with Crohn's disease, and she's Jewish, grandfather's blessing. She's involved in Judaism a little bit. I think she became involved in cancer genetics somewhat.
She became a
I didn't know
counselor,
that.
I think,
I did write to her and ask her if she would endorse the book, but she was going into the hospital and was old, and whatever, and so she never got to it.
I was thinking that maybe she can open doors for you to go and speak,
I
she's so
can write
well-known.
to her again. I can write to her again. I do know her.
Wonderful.
Not well.
Yeah.
I know her through texting and
Her writing.
and yeah, she sent Tim a book because he wrote a beautiful thank you to her, and I sent her a painting. So I do have, because I am an artist, I have a book that I could pass around of my drawings of my family, and then there are some of these pictures that are from the book, my father and his father and brother, my grandmother, the little boy who died young. This is the heartrending picture of my niece hours before she died, when she was out celebrating her husband's 37th birthday, and they just went to the restaurant and she died. And this I showed you before was me in high school with my friend Wendy. So there's also, I think, something from JScreen, which offers a cancer screen for about $300. They'll do the whole cancer screen. It's not the hard screen, but it is a proactive cancer screen. So I've told you about Connect My Variant, JScreen. Pardon me?
Which one is better?
I don't know which is better. I mean, they're good. What I like about Fulgent Genetics is that it includes everything. So I've been after JScreen to have a heart, but that's just for cancer. So it depends what you want.
But I had a quick question. How about for the ancestry or ancestry.com that checks your ancestry? Which one do you recommend better?
Those are not things that are going to help you for disease at all. So that's something that people need to get straight. They were great for me to help me find some relatives to warn about the disease. So you can find your cousin that you didn't know about, your, various relatives that you didn't know were relatives through Ancestry.com. and that helps you, that it did help me find people to warn about this mutation, both 23andMe and Ancestry.com, and it's a lot of fun, but they're not clinical and they're not going to help you with disease mutations. For that you need something like Fulgent Genetics or JScreen, and there's many others, but many of them you need to have a doctor first make the prescribe it. And they, unfortunately, are looking for a reason that they don't necessarily get, so you have to talk them into it.
Doctors, they're not getting paid for that, so that's why they don't really do it.
It's not that they're not getting paid, it's that they're overwhelmed, they're doing a lot of stuff, they haven't been trained in it, they're frightened of genetics, they're not sure you need it. And I really, if any of you have connections where I'd love to do continuing education for physicians, they only need to learn a few things. There's a genetic counselor who can help you. It's not very expensive. You can look it up on the website. Basically, that's it. And then, over and over again, and people die and you can save lives, and penetrance. I couldn't believe I had this deal with that guy over there. When my husband, when Elizabeth McNally told us that we should have the children checked every year for cardiomyopathy, get an echocardiogram, he didn't want to tell them. He was afraid that they wouldn't want to get married, they wouldn't want to have children, they'd be frightened, blah, blah, blah. So we made a deal. And the deal was that I could tell them anything I wanted that day. But the next year, I couldn't say, did you get it again? Mm-hmm. And the next year I couldn't say, oh, did you do it again? And I couldn't remind them or question it. That was it, once. So that's what we did. And my daughter kept getting her echoes until the day I told her she didn't need them anymore. My son apparently went to his doctor, and his doctor said, does your mother have dilated cardiomyopathy? And he said, no, my mother's healthy. He said, well, then you can't have it. Mm-hmm. This doctor didn't know about penetrance, didn't know that I could have the mutation but still not be sick. So he never got an echocardiogram. And the day I told him, you don't have to anymore, I don't have the mutation, he said, echocardiogram? Was I supposed to be doing echocardiograms? So that's the other thing I want to teach doctors. Penetrance, it's not that expensive, there's genetic counselors. And I can do that in an hour. And you can save lives.
What is the role of epigenetics on actionable genes?
On what gene?
Actionable?
Actionable genes? It's not. Epigenetics is the actionable genes, they're really dealing with the DNA sequence, the actual adenine, guanine, thymine, and cytosine.
So there is
Epigenetics is a whole other realm. And the other whole realm is, we're only dealing with things where one gene causes one disease. There's a lot of diseases like schizophrenia or stuff where you might need 20 genes and different genes. That's much more complicated. We'll get there, but there's no reason, because that's so complicated and we can't deal with that, to not at least deal with the ones that we know are simple. It's just one gene causes one terrible consequence, and we can help you with that. Every gene and every illness isn't going to fall into that. There's some that'll be epigenetic, there's some that'll be multigenomic, and we'll have to see over time, how we can deal with those. So, yeah, genetics is more complicated, but we don't have to worry about all the complications in order to be a good physician and help your patients use the genetic revolution that we've had. So have I gone over?
Yeah, no, you're doing
No,
fine.
Okay.